Day 621 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2831. Find the longest equal subarray. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero index integer array nums and an integer k. A subarray is called equal if all of its elements are equal. Note that the empty subarray is an equal subarray. Return the length of the longest possible equal subarray after deleting at most k elements from nums. A subarray is a contiguous, possibly empty sequence of elements within an array. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 3, 2, 3, 1, and 3, and k is equal to 3. The output is 3, right? So we want to see, so this means we can delete up to at most 3 elements, and after deleting those elements, we want to create the longest equal subarray, meaning all of its elements are equal, boom, that we can create by deleting at most 3 elements. And then the output is 3, meaning that's the longest subarray that's the length of the longest subarray we were able to create. So let's take a look at the explanation just to make sure we're doing this correctly. So it says it's optimal to delete the elements at index 2 and 4. So let me go ahead and copy and paste this over here. So remember, we could delete up to 3 elements. We don't have to delete 3 elements. In this case, we're only deleting 2 elements. We're deleting the element at index 2 and the element at index 4. Boom. After we delete both of those elements, now we have a subarray of all 3's with the length of 3, right? So this is an equal subarray because, once again, all of its elements are equal. Boom. All of its elements are 3 and it has a length of 3. So that's why the output is 3. The output is 3 because of the length, not because of the element itself, just so there's no confusion there, right? We want to return the length of the longest possible subarray. In this case, it has a length of 1, 2, 3. So the output is 3. Now, just in case that didn't make sense, y'all, let's take a look at example 2. Before we get into it, let me just copy and paste this handy dandy visual representation over here. Now let's get into it. In example 2, our input nums equals an array of integers 1, 1, 2, 2, 1, 1, and k equals 2 this time means we can delete up to 2 elements. This time the output is 4, meaning we were able to create a subarray of length 4. So let's see how we did that. It says it's optimal to delete the elements at index 2 and index 3. So this is index 2. Let's go ahead and delete that. This 2 right here is at index 3. Let's delete that. And then after that, we're left with this. It says, after deleting them, nums becomes equal to an array of integers 1, 1, 1, 1. The array itself is an equal subarray, so the answer is 4. It can be proven that no longer equal subarrays can be created. So, in this case, after we delete those 2 elements, we have a subarray of length 4, all 1. So we have 1, 2, 3, 4. Boom. And since the length is 4, then the output is 4, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, for this solution, we are going to be using an index-based sliding window because that will give us a big O of n time complexity. Whereas if we wanted to check all the subarrays, that we could do that, but that would be big O of n squared time complexity. So an index-based sliding window will be faster because it's big O of n. So we're going to go with the index-based sliding window. Now, first thing we're going to do is we're going to create a dictionary to map each value to the list of indices where it appears. So we're going to declare a variable. Declare a variable called positions. And we are going to set that equal to a dictionary. Key is going to be an integer. Value is going to be an integer. Then we are just going to initialize it with parentheses like that. Now we're going to build the index list for each number. So we're going to say for I, or open up the parentheses, I comma num, come outside of parentheses, n nums dot enumerated. So this enumerated is going to get us the value and the index, right? So that's what this for I num is. I will be the index, num will be the value of that element, right? So this will return index 0, num will be 1. So it would be index 0, 1, right? This would be index 1, 1. This would be index 2, 2. This would be index 3 with a value of 2, so on, so on. That's what this enumerated does for us right here. Boom. Then we're going to just come right here and we're going to open up the brackets and we are going to say positions, square bracket, num, comma, sorry, I should be comma, default, colon, an empty array. So it's going to be an empty array to start. Then we're going to come outside of that. We're going to say dot append, open up the parentheses, I. So each time we see this num, we're going to append I over here, so which will be the index. So we'll be able to see the num, the value, and then we'll see the index right here. Boom. Then we're going to come underneath this, declare sorry y'all, not underneath that, underneath the for loop right here, declare a variable called result and set that equal to 0. Now we're going to process each distinct number independently. So we're going to say for, open up the parentheses, underscore, comma, idx, s, come outside of that, n, positions. We're going to open up the brackets. We're going to declare a variable called left equals 0. Boom. Then we're going to come underneath that in the sliding window over the indices of the same number. So we're going to say for right and 0 dot less than idxs dot count. We're going to open up the brackets and the number of deletions needed to make the subarray equal is in the window size minus the number of kept equal elements. So we're going to say while idxs square bracket right, come outside of that, minus idxs square bracket left, come outside of that, minus, open up the parentheses, right, minus left, come outside of that, is greater than k. Then we're going to open up the brackets and we're going to say left plus equals 1. Boom. Then we're going to update the maximum length of equal elements kept by coming underneath this, and we are going to say result equals max, open up the parentheses, result, comma, right minus left plus 1. Boom. Then we could just come right here, and all we have to do is say return result, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, let's see. Cannot convert by type any. So let's see. One moment, y'all. Oh, sorry, y'all. Sorry, y'all. This should be an array of integers, not just a regular integer. So now let's run it. See if that did the trick, because our default is an empty array, so we need our value to be an array of integers. Sorry about that. Now let's go ahead and submit it now that we know it's accepted. Let's see, and look at that, y'all. 106 millisecond speeds, 50% of users. We can get those numbers up. But right now, we just want to be able to solve the problem that is presented to us. I feel like this is a good solution for that. So make sure you get one more look at the code. This is the top part. Or actually, this is the whole code right here. Oh, no, it's not. This is the bottom part right here. Boom. So this is the bottom. This is the top, y'all. And yeah, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem.
See y'all then.